Let's see if I am streaming. Yes, I am. Alright. Advent of Code, day 8. Let's see. Up. Move that way here. Up. Yes, I am streaming. Wonder. Hmm. Let's see. Alright. Day number 8. Day number 8. Day number 8. Alright. You're still riding a camel across a desert island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled Maps. Sure enough, it's full of documents, your puzzle input. How about how to navigate the desert? At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the document seems to describe some kind of network of labeled nodes. Seems like you're meant to use the left-right instruction to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wastelands. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left-right instruction until you reach triple Z. This format defines each node of the network individually. For example, right, left, AA, BB, CZ, BB, C. Okay, so it's a graph, I guess. Starting with you need to look up the next element based on the next left-right instruction in your input. In this example, start with AAA and go right by choosing the right element of A. Ah, okay. It's kind of a graph, but not really, since there is only two connections each time. Okay. And this example, start with AAA and go right by choosing the right element of AAA, triple C, then L means choose the left element of CC, Z. By following the left-right instruction, you reach Z in 2 steps. Okay. Of course, you might not find triple Z right away. If you run out of left-right instruction, repeat the whole sequence as necessary. Really means... Oh, okay. For example, here is a situation that can take 6 steps to reach. So, follow the left-right instruction. How many steps are required to reach triple Z? Ah, okay. And puzzle input is Okay, so it's not okay. Should be simple enough, I guess. Just keep going left or right according to what they said, and then that's it. Go up. Okay, dir 08, 08. Oops. Let's 08 now. Touch main.odin, main.odin, and let's copy the start of 07. And not sure I will need this, not sure I will need this. And main that I will need up. Except it's not it's example. Odin run. Yes, and let's copy the example. Xclip example. I'll copy the real puzzle input because might as well. Input. Okay. Then we can do instructions, then a bunch of empty lines, then nodes, lines, nodes, strings, and this is strings partition of S by 2 new lines. Let's see if I'm correct. Instructions. That is correct. And can't say. Okay, yes, that is correct. And then for line in strings, split. Oh, why don't I have auto completion? Come on, give me auto completion. Split. Thank you. Split lines iterator S. So we need a list of nodes and yeah, I guess it's gonna be a map. It's gonna be a map and we need a struct. No, we need a left, right. Maybe let's go to neighbors. There's a struct which has left, which is a string, and right, which is a string as well. Then we have nodes, which is a map from string to neighbors. Let's initiate this and then defer, delete nodes. And so for lines we can do label, then this, then neighbors, oops, string is string partition line with this, yeah, and then we do left, this, right is strings partition neighbor strings based on this. And then we do left is equal to left 1 to skip the first parenthesis, and then right is equal to right Can you do this? I don't think you can. Let's do just len right -1 this, and we do at the very end nodes label is equal to neighbors left right like this, and here let's print the results nodes. Hop. Hop. Invalid indices is orange. Print ln left right. Oh. Never seen it. Oh, okay. My bad. This needs to be nodes string. Nope. This. Okay, no prints. Let's see. So, and the example was 3 nodes. Oops, let's go like this. So ZZ. Oh, but that's very strange. Print ln label left right. That is quite strange. That is quite strange. Print ln line. Okay. Print ln label. So label is good, and neighbors strings, that is good as well. And yeah, then I don't know. Let's see, left, right. Yeah, it sounds good. And then what happens? Ah, it's normal. Wait. So AA has... So confused with the example. Oh, okay, it's just that the example looks buggy. Okay. But BBB has A and Z. Alright. I'm good. Alright, parsing is done. Then we do for instruction in instructions. And we do current label is AAA. Yes, trust me, bro. And we do if instruction is an L, we do current label is equal to nodes current label left. Otherwise, we do current label right. Et ensuite, we do if nodes current label. No, if current label is triple Z. We break, and we need to step count, and we need to count from 0, and every time we do this, we do step count plus equals to 1. I think that's it, huh? If I understood correctly. Of course, you might not find the if you go left right instructions. Ah, yes, because I need to repeat. So it's while no, yeah, for current label is different than the. We do this. And I need to, yes, put that here. Let's see, 5. So I just need to put this here, and we have a 6. And let's try with the second example, like this. Let's clip into example 2. And if we do example 2, 2 steps. Okay, let's try with the real input. Huh? Right. Let's see. Yay! Okay, that works. But that was very easy. I assume the second part is gonna be very difficult, because that's how it works. If the start was easy, the end is impossible. Of course. Up. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting point. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the law of space-time? Only one way to find out. After examining the maps, a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number of ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all the paths at the same time until they all simultaneously end up at node that end with Z. Okay. So here there are 2 starting nodes, 11A and 2, because they are both A. As you follow, use that instruction to simultaneously navigate away from both nodes you are currently on. Repeat this process until all of the nodes you are currently on end with Z. If only some nodes you're on end with Z, they act like any other node and you continue as normal. Oh, okay. So it doesn't stop if you've reached Z for like one of them. You have to reach Z for all of them. Okay. In this example, you would proceed as follow. Okay. So in this example, you want the node that end in Z after 6 steps. Simultaneously start on every node that end. How many steps does it take before you're only on node that end with Z? Alright. That It actually doesn't sound too complicated. Maybe I'm wrong. Example 3. Example 3. Yeah, that obviously doesn't work. So that was part 1. Next, we need current labels, which will be an array of a string. Let's make it dynamic. If limits current labels, and we do for label in nodes, do if label 1 is equal to a, do current labels no, we append current labels label petit println labels, no, current labels, up, yeah, and obviously this isn't going to work for that example. Oh no, it's that end with an A starting node, and it is the one that end with a Z. Okay. So it is 2 here. Okay. And then we do for I think using slices will be nice here. Or slice all of proc for current labels. Then we do proc of L, which is a string, which returns a bool, and it is return L3 is equal to Z. And this is a syntax error. Why? Expected got machin. Yes, forgot to close it. Can I determine type of polymorphic parameter dynamic string into? I think I need to do this. Yes, oh. No? Ah, yes, no, it's not 3 here, it's 2. Yes, okay. Not. And this should be an infinite loop. Yes. So, and then we just do this again, I guess. For instructions and instructions. But we, instead of this, we do, let's make a loop up, for current label, and in current labels, this, and then we do current labels I is equal to node current label left. Yes, I think that's correct. And then we do exactly the same thing for right. And this, I guess we don't have to do. And we do this, like this, and let's see, 6. And in that example, they say it is 6. Let's try with input. Input. Oh. I need to make some tricks because it's really, really slow. And last time I did that, I made OBS or the stream crash. Are you crashed? Nope. Oh. Are you crashed? Okay, so there is some optimization. Okay. Where does it take so much time? Input for the 8 is 800 long. How can we optimize this? I think the condition is not gonna change. Wait, I got lucky for this one. It's not supposed to be this, I think. I think you're supposed to have a condition. Oh, wait. Ah, yes. I do have my condition. It's that one. Yep. So I need to do if this is true, do break. And this can be commented. Let's see. Let's try to cheat. Let's try to cheat. And yeah, I'll wait 30 seconds, but not more. Not more. Huh. Wall of proc. Yeah. All right. Let's stop it. And if I redo the example, example 3, I think it was. Yeah, that's still 6. Let's read it again. Here there are two starting nodes, this and this, because they both end with A. As you follow each left-right instruction, use that instruction to simultaneously navigate away from both nodes. If you are currently on, repeat this process until all of the nodes you are currently on end with Z. If only some of the nodes you are on end with Z, they act like any other node and you continue as normal. This example, you would proceed as follow. You choose all of the left paths leading you to 1B. You choose all of the right paths, you choose all of the left paths. Okay. So in this example, you end up entirely on nodes that end in Z after 6 steps. Simultaneously, you start on every node that ends with A. How many steps does it take before you start on every node that ends with A? Every node that ends with Z. And yeah, that's tricky. So I have currently the brute force approach, but I guess I have to be a bit smarter. How can we optimize this? Algorithmically. Let's first just create a small proc like all nodes nodes all ending, which is just a proc that takes labels all ending labels, which will be in this case a slice of string. Bool, and this is just this. Up. Okay. Okay. What was the number for the first one? 18,000. Yeah, I think they highlighted the significantly more steps for a reason. It doesn't sound like too much of a problem though, huh? Because you just repeat the instructions again and again and again. It's kind of like counting. Mm. I guess for each instruction you have to shift everybody as well, so maybe that's costly. Is there already an Odin? I mean, I guess I don't really need a profiler. We know it's already simple. There is no like hardware or like badly optimized. We know the code just spins around in this. Huh? How? Actually, can't we find the number of steps for each of those nodes and independently, just like part one? And then we just find the lowest common denominator for them. Maybe that would work. Because like for a node, if you repeat it, like the exact same amount it took to get to the end, you will get to the end again. So yeah, that sounds accurate. So I would do comment this for a while, then take back my example, except I do need this, and I need to copy paste this. Up. This can stay the same. So I have my current labels, and we are gonna do a first pass. So we do for current label in current labels. We do this like this, and then we do lowest common denominator, I think. No. Labels steps, which can be, we don't need to keep the label, we can just have this as an int. Actually, this can be a slice that we make that is of length current labels. Since it's the exact same size, delete labels steps. And so in that case, we do for current level. Yes, this is, but that's not it. 2 is different than z, and then 2 here different than z, and then we do this, and current label is already created, and can do that. I do current label is equal to current label, and I shadow it. So that's, yeah, that seems right. And we can do a function print ln here, step count. And yes, is there a lowest common denominator thing? Lowest common denominator. What is this? Oh no. Math. No, yes, but I mean UTF-8. Let's search lowest common denominator. Lowest common denominator, lineage. log nope. What about in math? I mean, it's not a hard function to implement, I guess. But see, lowest, low, okay, no. Oh well. Oh well. This function. Lowest common subsequence. Oh no. Lowest common denominator. Okay, I need lowest common denominator. And by the way, I didn't test this, but like if I try this on input, it should be way faster, right? Just run it like this. Yes, it's way faster. And I just have to find the lowest common denominator between those values. So, actually, can I do it with this shitty online calculator already? I wonder. Wait, that would be funny. That would be funny. Let's up and we just want to separate those by commas. He said up. Anything else? Calculate. Colon fraction LCD. Least common denominator. Maybe least common denominator doesn't mean what I think it means. Yeah. Great test denominator. How is it called again? Like the greatest common factor. Okay. I think that's it. This, and this. See. Enter only numbers. Okay. He doesn't want space. That's a very picky calculator. What? No! Ah yes, but that's not it either. Ah, for fuck's sake. Highest common factor, greatest common divisor, GCD. Let's see, is there a GCD in there? I think I'm confusing just all four of them. So, greatest common denominator would be the greatest common factor. What does that mean? Greatest common factor, greatest common denominator. Highest common factor. Greatest common divisor. Okay, they use factor as like the number that is that is dividing. I don't want that. Euclid's algorithm calculator. No, okay, so in my case, those are the factors, and I want to get the minimal number for which those are factors. Is there like a greatest common multiplier? That sounds strange. Greatest common factor and least common multiple. Greatest common factor example. Lowest greatest common factor. Least common multiples. Oops. Greatest common factor. Least common multiple. Least common multiple. The least common multiple also refers as the lowest common multiple. Yes, that's what I want. Two integers. The smallest positive integer that is evenly divisible for both A and B. Okay. I think that's what I want. Let's see. Oof. That sounds like a lot. That's like millions, billions, quadrillion. Okay, I mean, let's try. Did I put the correct value here? Or... Yeah, seems like it. It's suspicious because it's more than the 32-bit integer limit, and I don't think Advent of Code would do that. Like 31. This is only billions, right? Yes, this is 4 billion. And here we have like a lot more. So I don't think it's that, but we can try. Oh! Let's go! Oops, I fucked up the mic. Oh, I'm so happy that that shitty calculator online calculator worked. Let's go! Tricks! Mathematics! I'm a mathematician. Ah, man. This is so stupid. So it's called least common multiple. And is there by any chance a function? Least common multiple. Oh, there is! Incredible. Least common multiple of these and these. And I guess you can just chain that. And so. Boom, boom, boom. We do labels steps. I don't use it yet, but I do just labels step. Let's just call this steps, step counts up, and we do happens this step count, and indeed it's not dynamic, so it's an I, and we can just do this and do